Hi guys, welcome to our last day of practice with factoring, and we're actually just going to continue working with factoring, but seeing how we can use factoring as a tool to solve quadratic equations. So your learning target is I can solve quadratic equations by factoring. First of all, in order to solve a quadratic equation by factoring, it must be in this form: ax squared plus bx plus c equals 0. When we are solving an equation that is set equal to 0, like this one, its solutions are called zeros. And I've put the definition of zeros of a function here in this box. The zeros of a function are the x value or values that make the y value or f of x value equal 0. So as you notice, generally in our standard form, and over here where 0 would be, it would have been y or f of x or g of x or whatever you called your function. So we're seeing what x value or x values we can put into this equation that would make it equal 0. All right, so here's our first example of solving an equation by factoring. I have listed some steps here for you to have when you're working on your problems by yourself. Solve the equation x squared plus 10x plus 21 equals 0. The first thing we need to check and make sure is that the equation is set equal to 0. And if it wasn't, we'd have to move everything to one side of the equal sign. This one right now is great, already set equal to 0, so we can get to factoring. I'm just going to rewrite the problem over here so that I have a little more room to work with. Okay, so this is one of those easy ones where my c value is positive and my b value is positive, so I know that both of my factors are just going to be x plus something, especially because my a value is 1. Okay, so I list the factors of 21, and I pick the pair that adds to 10, and that would be 3 and 7. So my factors are x plus 3 times x plus 7, and that's still in my equation set equal to 0. Once I have factored, I use the zero product property. The zero product property states that basically anything multiplied by 0 is 0. We know this. We learned this a long time ago. Okay, so anything multiplied by 0 equals 0. So what that means for us is we need to figure out, remember that what this says is x plus 3 times x plus 7. So these are our two factors. If one of those factors was 0 and we multiplied it by the other factor, the entire thing would be 0. So to figure out what would make each of those factors equal 0, I set each factor equal to 0 and solve. And that's what we do every time. Okay, so I'm going to write that down here under where I just started writing everything. So x plus 3 equals 0. That's my first factor. My second factor is x plus 7. I set that equal to 0. Now these are simple solving. I would subtract 3 over here and get x equals negative 3. And I would subtract 7 over here and I get x equals negative 7. So I have two solutions, or two zeros, to this function, x squared plus 10x plus 21, when it's set equal to 0. So if you wanted to check to make sure that that actually would work out, you could plug it into the original equation, or you could even plug it into our correctly factored equation. And if I put a negative 3 in there, negative 3 plus 3 would be 0, and 0 times, doesn't even matter what would be in my second factor, would be 0. And if I put a negative 7 in here, I would get 0 in this factor times whatever this first factor was, would still get me 0. So I give my answers, as it says in step 4, as x equals whatever those values are. So we're going to try a few, and then the ones we do not finish, we'll finish in class together. All right, solve by factoring. So let's look at our first one, which is x squared minus 9x plus 20 equals 0. My first step is to make sure that it's set equal to 0, and this one is. My second step is just to factor. I just have x squared, so we know the first terms in our factors are just going to be x and x. Next, I see that my c value is a positive 20, but my b value is negative. That means that both of my numbers have to be negative if they're going to multiply, be positive, and combine and add together to be negative. So now I'm going to list my factors of 20 and pick the pair that adds to 9. Looks like I'm going to pick 4 and 5, so I'll have x minus 4 times x minus 5. Now I use the zero product property, set each factor equal to 0, and solve individually. I would get the answers of x equals positive 4 and x equals positive 5. Okay, moving on to b. I have x squared minus 8x minus 20 equals 0. Is this one set equal to 0? Sure is, so I can start factoring. My first term is x squared, so I know this has to be just plain x and x. And I look at my c value, it is a negative 20, which means that to multiply to be negative, one of my factors has to be positive, one has to be negative. And so what I'm going to ask myself is which factor pair has a difference of my b value, which is 8. So I look here, 2 and 10 have a difference of 8, so I know those are going to be my values I put into my factors. Now I want it to be a negative 8, so I would want this to be a negative 10 and a positive 2, since negative 10 plus 2 gives me negative 8. Then setting these equal to 0, I get my solutions of x equals negative 2 and x equals positive 10. All right, moving on to letter C. X squared plus 7 equals negative 8x. This is our first example where it's not set equal to 0, so I'm going to have to add this 8x to the other side. And then make sure that you write this in the proper order, x squared plus bx plus c equals 0, so that we can think of factoring in the correct order. Looking at my c term, it is positive 7. My b term is positive 8. My x squared is just plain old x squared, so this is one of those easy ones where I know I have x and x as my first terms and my factors. 7 is a prime number, so my only options to multiply by to 7 would be 1 and 7. And sure enough, 1 plus 7 does give me 8. So setting each of these equal to 0, I get x equals negative 1 and x equals negative 7. All right, looking at D, n squared equals negative 8 plus 6n. Now, we need these all to be on one side and 0 on the other. And some of you might say, well, why don't we just subtract n squared? And I'd say, well, we could do that, but we don't ever like to factor with a negative squared term. So instead of doing that, I'm going to add 8 and subtract 6n on both sides. So that's going to give me n squared, and then I'm going to put the minus 6n in the middle, and then plus 8. Equals 0. In this problem, my c is a positive 8, my b is a negative number, which means that both my factors are going to be subtraction, because two negatives will multiply to a positive and add to a negative. So I list my factors of 8, and I pick the pair that adds to 6. Sure enough, I would have a negative 2 and a negative 4. When I set each of those equal to 0, I get my solutions of n equals positive 2 and n equals positive 4. Okay, let's look at E. E is a little different than ones we're used to. This isn't the proper form, it's just that our c value is 0. And whenever we have a c value that's equal to 0, we just need to pull out the GCF of our two terms, and we can solve the factors that way. So if I look at 5x squared and 4x, I can take out an x from each of those terms, and I will have x times 5x plus 4. So essentially, my first factor, you could write it as x plus 0, but we don't need to do that. This is a factor in itself, x. And so when I set that equal to 0, I right away get one solution. If I put 0 in for x, I would end up getting 0 out. But then if I set this factor equal to 0, I have a little more solving than we're used to. I'm first going to have to subtract 4, where I have 5x equals negative 4, and then divide both sides by 5. And go ahead and just leave your answer as x equals negative 4/5. So I have two solutions, 0 and negative 4/5. Letter F is also a binomial like letter E, but it's actually different. If you notice, this is 25x squared minus 9, which would be one of our special cases because it'd be like we had a 0x in the middle there. And remember, that's from a difference of squares binomial that factors two separate factors that are opposites of one another. And remember, we take the square root of the first term and the square root of the last term. Square root of 25x squared is 5x. The square root of 9 is 3. So I know those are my two terms that will be in each factor, but each factor is opposite. So one is plus and one is minus. Now, we will set both of these equal to 0, but I hope that you see